Okay, so on this sheet I asked you to do numbers 1 to 4. And number 1 says a 0.155 kilogram billiard ball is rolling straight across a table away from you with a speed of 5.5 meters per second. It collides with a stationary golf ball that a friend of yours has placed on the table for fun. The golf ball's mass is 60 grams. So notice grams and kilograms, so you have to change one of them. Let's go to kilograms. After the collision, the billiard ball rolls off at an angle of 22 degrees counterclockwise with its original direction, velocity of 4.8 meters per second. Okay, so here we have our V1 initial is 5.5 meters per second, and it says it rolls off 22 degrees counterclockwise. So counterclockwise from the original will be up like this. So this will be ball 1. So this is V1 final. This is, was it 21 or 22? 22 degrees, and it's 4.8 meters per second, which means V2 will go this way, ball 2. So this will be V2F, and that's what we're looking for. So this guy has a V1F y, which we can find because we have the hypotenuse and the angle, and it has a V1fx, which we can also find because it has a hypotenuse and an angle. And then the V2fy and the V2fx we will get from our equations. Okay, so we go to conservation of momentum, starting in the x direction, m1 v1 initial x plus m2 v2 initial x will equal m1 v1 final x plus m2 v2 final x. Initially ball 2 is not moving at all, so it goes to 0. We're looking for v2fx, so we can bring this fellow over. So it'll be m1 v1 initial, and it's all in the x direction, so I can drop the x, minus m2 v2, oops, sorry, those are 1s, m1 v1 f, and in the x direction, that's cosine. It's the adjacent side. So cos theta will equal, and I want v2fx, so let's divide by m2. So v2fx equals 0.155 kilograms times 5.5 meters per second minus 0.155 kilograms times 4.8 meters per second times the cos of 22 divided by 60, whoops, I wrote grams there, but it's really kilograms, it's really grams, so 0.060 kilograms. Punch this all into your calculator, and when you do, you should get 2.71 meters per second. Yes, there are more decimals than that, but that's all I'm keeping. Then we go to the y direction. So m1 v1 initial y plus m2 v2 initial y equals m1 v1 final y plus m2 v2 final y. Now take a look at this. What are they doing in the y direction? They're not doing anything. Both of the initials are 0. So bring your m1 v1 final over, and in the y direction it's the opposite side, so it should be sine, and that'll be equal to m2 v2 final y. Divide both sides by the m2. So v2 final y will equal negative 0.155 kilograms. V was 4.8 meters per second. Sine of 22 divided by the 0.60 kilograms. V2Fy equals negative 4.645 meters per second. Okay, once you have that, now you can find, whoops, get back there, paper. Now you can find your V2F. So in the x direction, we had, what was it, 2.771 meters per second. In the y direction, 4.645, and the negative just meant opposite number 1, so going down. So then this will be V2F, and this will be theta. So square them, add them together, take the square root, use tan to find your angle, and you'll get V2F to be 5.378 meters per second at an angle of 59.74 degrees. And which way? Clockwise, or ridge. Okay? So hopefully these are getting easy for you by now, because it's just the conservation of momentum being applied in the x direction and the y direction. All right, number 2, I believe it's an explosion. It's G.I. Joe. Okay, so for those of you that are not as old as me, G.I. Joe was an action figure who was in the army or something. And kids played with them and were quite protective of them. So here's my G.I. Joe, and he explodes into 3 parts when you hit a remote control. I guess you don't like other kids playing with your toys. A 16-gram piece is okay, so do your X and Y. Okay, so it says a 16-gram piece is thrown off at an angle of 35 degrees counterclockwise with the positive X. That's up this way. So here's piece 1 going this way, angle of 35 degrees. Piece 1 has a mass of 16 grams. And then a velocity, v1, and remember it's a final, 25 meters per second. This kid, you really don't like sharing your toys. A second piece, 14 grams, is flung off at an angle of 21 degrees counterclockwise with the negative y. So my negative y is down here, and counterclockwise will be this way. So this is piece 2, going this way. And it says this piece is 14 grams. And it says the angle in here is 21 degrees. So V2F is 18 meters per second. Okay? And so, what is the mass and velocity of the third piece? Well, the total G.I. Joe is 40. And we already looked after 30, so piece 3 must be 10 grams. And piece 3 is going to go out this way, and I'm fairly sure it's going to be fairly close to the, I bet, x-axis. Let's go up. I might be wrong. Okay, so this is piece 3. It's 10 grams. We're looking for V3F. And so again, you're going to do conservation of momentum. Initially, in the x direction, m1 plus m2 plus m3 v initial x will equal m1 v1 initial, final x plus m2 v2 final x, m3 v3 final x, initially at rest. Again, before you rearrange, look after your positives and negatives. Your piece 1 is positive in the x, so it'll be m1 v1 final, and that will be cosine theta 1. Your piece 2 is also positive in the x, so m2 v2f, but look where it is. It's going to be sine theta 2. Plus m3 v3fx, which should work out to be negative because it's definitely going in the other way. So rearranging v3fx will equal negative m1 v1f cos theta 1 minus m2 v2f sine theta 2 divided by m3. So v3 final x is equal to negative. Now, you could change these to kilograms if you want, but they're all in grams, so it's okay to leave them in grams. This is 25 meters per second. Cos of, what was that, 35? Minus 14 grams. Is it just me, or is that blurry? Might just be me. 18 meters per second. Sine